finally we come to the last videos of transition metals. So in this video, we're going to talk about the importance of transition metals and their compounds in our daily life. So first of all, in the industrial process, actually we require transition metals and their compounds to catalyze the reaction. So this table, actually we put all the reactions, we described it in the textbook. You need to know, you have to know the name of the process. Actually the equations it must, to be honest, many of them you've learned that already. I would say better you memorize this as well. But for the condition like the temperature and also the pressures, unless I especially tell you which one you have to remember, but most of them actually you don't need to. And most important is you have to know that what kind of catalyst you have used. So the first one is a HAPA process. We turn nitrogen and hydrogen into ammonia. Ammonia is very important to us because it can then used to manufacture fertilizers to increase the crop yield and things like that. In the process, we are using finely divided iron. So finely divided iron, that means they are like powder form. So this can increase the surface area, increase the active site for the reactions to occur. So second one is contact process. Last videos, the exercise we mentioned that. In process, actually we produce sulphur trioxide. We use sulphur dioxide and then combine with the oxygen to force it to become sulphur trioxide. And sulphur trioxide, later on we can use that to manufacture sulphuric acid. So we are using vanadium 5 oxide as a catalyst in these situations. Next, we are talking about the decomposition of hydrogen peroxide. Hydrogen peroxide can be catalyzed by manganese 4 oxide. So this one should be 4 oxide, not 5 oxide, sorry. So this one have to be 4 oxide. So more details, we'll cover it in the rate of reaction in chapter 37. So in the process, the hydrogen peroxide, it will decompose on itself. If you leave the hydrogen peroxide in room condition, it will slowly decompose. But if we have manganese 4 oxide, it can decompose faster to give the hydrogen and water in the process. So if I remember correctly, actually if you study biology, they also have similar reactions showing to you. They have put liver into hydrogen peroxide, and you'll find that the liver can help to catalyze the reaction. You put the liver into the hydrogen peroxide, and then a lot of bubbles will be coming out immediately, because inside the liver they also got some enzymes, get some catalyst to speed up this reaction. So in organic chemistry, in book 2, we did learn about catalytic converters. We convert some toxic or poisonous gas like nitrogen monoxide, carbon monoxide into N2 and also CO2. So in the process, we try to reduce the harmful gases emitted from the car. So these reaction, actually you did learn it before. So we have used platinum or rhodium, to act as a catalyst. But one thing I want to remind you, the platinum, they can be poisoned, by lead or lead compound. That's why, if we use catalytic converters, we need to use unleaded petrol in the process. So just a quick review. Remember, in the catalytic process we have 2 steps. First half and second half. So first half, you see that the nitrogen monoxide combined with the carbon monoxide to give nitrogen and carbon dioxide. Second half, we put oxygen in it. We speed up the reaction between the carbon monoxide and oxygen to form carbon dioxide, and also break down the unburned hydrocarbon to carbon dioxide and water. So last one, it will be production of polyethylene. We also learned that in book 2, the addition polymerization. We did learn that polyethylene from ethene, and then they repeat itself, and open the arms, become square bracket N. So in the process, actually we did have 2 catalysts, but actually the first one, we don't need to mention, so we just focus on titanium chloride will do. So these are some of the industrial process, which require transition metals or compounds to act as a catalyst. So you have to bear in mind. Next, we are talking about the application of transition metals. Sometimes they are not necessarily used as catalysts. They themselves can be used as a raw materials to making different kind of things. Okay, so you have to bear in mind. Okay, try to memorize as much as possible, but most likely, okay, you will find this, okay, in the MC. The one I show you pictures, okay, actually it is quite common to be seen, okay, in the questions. Okay, so pictures can help you to memorize better. So for scandium, okay, we'll use it to strengthen the aluminum alloy and use it in the airplane. Okay, titanium, okay, they can make aircraft. Okay, this is quite common. Just how we did mention, okay, we can use it to catalyze the formations of polyethylene. Okay, and also titanium oxide is quite commonly used pigment, okay, in paint industry. Vanadium 5 oxide, vanadium, okay, we can use it to make steel. And also vanadium have a lot of colors, okay, so therefore they can make it as dye. Okay, vanadium 5 oxide we did mention just now in the contact process. Okay, so this kind of screwdriver, sipala, okay, we can use vanadium, okay, as a kind of making the steel. Okay, and chromium, okay, we did learn that, okay, in corrosion of resistance, okay, or corrosion of metals. Okay, we can use it as chromium plating the car bumper. Okay, very shiny one. Okay, and also we use it to make the stainless steel. Manganese, okay, you just remember dry cell, okay, alkaline manganese cells. So we use manganese right there. Okay, so actually you can find, okay, the transient metals we use a lot, okay, in the steel. So if you really can't recall, okay, what is the function of that transient metals, just say manufacture of steel. Try your luck, see whether it can okay or not. Okay, so next, okay, for the iron, okay, we again, you can see that we make steel. Okay, we use it to make steel. Okay, and finely divided iron, okay, we learned this one in book 5, okay, extensively, okay, because we learned Haber process at that time. So cobalt, okay, we can use it in a batteries, okay, like the lithium ion batteries, but in details we didn't learn about that one. Okay, so cobalt, okay, we can use this one as a source of radiations to kill cancer, okay, to kill cancer cells. Okay, and also we use it in super alloys, but I don't think you can memorize these things. Okay, so nickel, okay, we can use it in nickel batteries. Okay, so the green one, this one, okay, actually is a nickel batteries. Okay, so we can use it to catalyze hydrogenation reaction. If you still remember hydrogenation reaction, we are talking about a alkene, and then we get hydrogen in it, so we have nickel added in it. Okay, it's 100 to 150 degrees Celsius. So later on you'll learn a little bit more, turning alkene to alkane, okay, when we talk about the organic chemistries. Okay, then you can revision, okay, on that. So copper, okay, needless to say, okay, electric cables, okay, use it make pipes, okay, make alloys like bronze and brass. Okay, zinc, okay, we can use it in galvanized iron. We can also use it in zinc carbon cell. Okay, that is part of the elements to make all the brass as well. Okay, so galvanized iron, we just recall your memories. Okay, if scratched, the surface of this galvanized iron, can the iron underneath still protect? The answer is yes, because we can have sacrificial protection. Okay, zinc is more reactive than the iron, so therefore it can lose the electron more readily to the iron. Okay, and can still protect the iron. Okay, so that's the applications. Okay, usage of the transient metals in daily life. And examples, okay, trumpet shows right here. This is a brass, right? So brass, just now we mentioned, it will have like copper, we have like zinc, things like that. So major transient elements, okay, making brass, okay, you have to remember, or just how we mentioned, copper and also zinc. Say one other use of each metal in case or give the property of some metal that make it suitable. So copper, normally we say electrical wire because they have a good electrical conductivity. Zinc, you can say that galvanized iron, just how we mentioned, because zinc is more reactive than iron. It protects iron from losing by sacrificial protection or things like that. Okay, so more or less, okay, the application. So you have to remember some examples and some of the features of why can they be used. So last one, okay, we talk about the importance of trace metals in maintaining health. Actually, they are a lot of trace metals, not a large amount, but we do need trace metals, okay? They're in our biological system inside our cells. So the biological catalysts, okay, we call those enzymes, okay? These enzymes always contain trace metals, and they can help to catalyze biochemical reaction. So we're going to introduce two of them. First of all, okay, we will have synthesis of vitamin B12, okay? So this one, okay, it can help the functions of the brain, nervous system, and also formation of blood. So you can see the pictures here, okay? This one, okay, is a vitamin B12, okay? Right in the center of it, you can see, right in the center of it, you can see cobalt. Okay, so actually cobalt is very important in forming B12. Okay, second one, okay, is a hemoglobin. Okay, I think you are very familiar with this. Okay, hemoglobin, okay, responsible for transport oxygen. It's just like carrier combined with the oxygen. So this iron in the middle, okay, is combining the oxygen and help the red cell to carry the oxygen in the process. Okay, so hemoglobin is even more important. So very, very important examples. Okay, so for this videos, okay, we did record the trace metals and compounds used in speed up different industrial processes. Okay, S is missing. So and we also talk about some of the uses of it in our daily life. Okay, you have to know when or where we are using these trace metals, and also we know that okay they are very essential to maintain good health in ourselves. Okay, they are incorporated in the enzyme. Okay, combined with the enzymes to catalyze some biochemical reactions. So, two examples: we have cobalt in B12, we have iron in hemoglobin. Okay, so that's all for this chapter. Okay, about the trace metals. Bye bye.